though it's a little lengthy. Second definition. It is the ratio of the sum of, just a moment please, it is the ratio of the sum of a number of values to the total number of values. So just check the definition. It is the ratio of the sum of a number of values, sum of a number of values to the total number of values. That's the second definition. So more clearly, it will be actually much more clear if it's written like this. Just observe, it's the ratio of the sum of all the values to the total number of values. So sum of all the values, I'll just make it slightly change, all the values. This is much more clearer. It is the ratio of the sum of all the values. Actually, it comes as all the values of a quantity, but that's not required. So of a quantity means it always looks like some physical quantity, but it not be physical quantity. Any group of values it can be taken. Say the physics marks of a group of students. So it's not a physical quantity. So it doesn't appear to be, it's not always a quantity. So this is much more clearer, accurate definition. It's the ratio of the sum of all the values to the total number of values. So this is much more accurate. So all the number of sum of a number of values, also it's okay, but this is much more clear. It's the ratio of the sum of all the values to the total number of values. So that is nothing but this. Just see here. This is the second definition. Sum of all the values to the total number of values n. So k ranges from sigma qk, k ranges from 1 to n. N is missing here, so because actually it got erased when I was shifting the equations upwards or from the right to the left like that. Doesn't matter, now this is more complete. So this is the definition. Just see here, there's nothing wrong here. Sum of a number of values to the total number of values. But number, it's actually something like number. So they're actually having different uses. So it's actually not easy to by heart it. Always the definition is given in such a way that it gives the simplest meaning and very easy to remember. Remember means by heart also. By hearting is also not to be taken lightly. It also is very, especially definitions should be by hearted, scientific definitions, because they are given by different scientists by careful observation. One word changes also, its effectiveness is to some extent gone. So these definitions are given only in some textbooks. So as it is, I have given some textbooks, slightly different words are there, but they are a little more difficult. So I have given the simplest, I have given the definitions in the simplest possible manner. Few books, they have given these definitions as exactly like this. So nowhere, nothing is wrong here. So brackets, I'm not cancelling it. I'm just putting not required, just into I'm putting here, not required. Just remember it. It is the ratio of the sum of all the values to the total number of values. So it's looking rhyming also. Sum of all the values to the total number of values. So it's very easy to remember. So this is the second definition. So next, very important thing, note. This is a note point. A very powerful note point. Just see here, very simple note point. So this immediately follows from the where? From the second definition. This one. This should be taken not in the rough column but as a continuation. So note, Q average is equal to Q1 plus Q2 so on. It can be seen that it's greater than Q minimum. Some minimum, all the values we are taking it to be equal to only minimum value among the n values. So Q minimum n times. So from this what we are getting is very simple result. So Q average is greater than Q minimum and here lesser than Q maximum. So it's not very clear. Just observe here. Don't try to be in a hurry to write this. So Q average is greater than Q minimum. So always the reasoning steps are the most powerful steps in science and technology. So we are reasoning that we are getting a very simple result from reasoning that Q average is always greater than Q minimum and Q average is always lesser than Q maximum, the maximum value among the n values. That means Q average lies between minimum and maximum. So this is a very powerful result. Now observe one small thing. Now assume that all the values using in some very special situation, a certain quantity when it is measured n times, all the values or by some coincidence all the 60 students of the class, the physics marks are exactly equal. Exactly equal. All the 60 students are getting say 100 of 100. This is 100, 100, 100, 100, all the 60 students 100. Then what is the average? So 60 into 100 by 60, it is 100. So the class average is also exactly equal to the each student marks. So if all the n values are exactly equal to each other in a special situation, usually it will not be happening. Usually it will never be happening unless, so for example, it's only in ideal situation. If all the n values are exactly equal to each other, then what is the average? So n into all the values are equal. N into each value, take it as say Q naught. All the values being equal, denote them by simple symbol Q naught. N into Q naught by n is what? Q naught. So the average is also equal to each value. So minimum value is Q naught, maximum value is also Q naught. Average also is Q naught coming. So that happens only in a special case. In that special case, average value will be equal to the minimum and maximum value, equal to Q naught. Minimum and maximum values are equal. So equal to symbol is also can be written. So in general, it always lies not equal to but in between, exactly. Inequalities equation is actually inequality symbol only should be used, but in special cases it can become equal to the both the minimum and maximum also. That is when all the values are exactly equal to each other. So this is taken as general result. So whatever things we are seeing here are simple, nowhere any complication is there. So that's the thing about average. Now see here how simple the definition is. Many times we have used the definition, but we have to cover the original scientific definitions are the most important things, because always it cannot be said that certain problems are there, will be there, which require the actual original scientific definition. Without that, the particular problem cannot be solved. So each and every scientific definition must be understood thoroughly, though it takes a little time. So that's the thing about the average or arithmetic mean, or simply mean of a number of values. So this running notes must be completed now itself within 2 or 3 minutes. You must be taking, and then you must be, so put the video to a pause and complete the running notes quickly, or take the screenshot of this and the screenshot of this and complete the running notes, and then listen to the next topic. So whatever things we are saying here are simple, nowhere any complication is there. So now the next topic, very important topic, which is actually based on the definition of average. So the uniform, just observe the topic here, observe the cursor. So uniform, the topic is actually consists of 4 different quantities definition: uniform electric current, non-uniform electric current, average electric current, and instantaneous electric current. Now the first quantity here is the uniform electric current. So what is the definition of uniform electric current? So definition: uniform electric current. I'm just putting the short side heading. So how uniform electric current is actually defined. Now the definition is almost similar to the definition of uniform velocity or uniform speed. Now just check the actual definition of electric current or the strength of electric current. So actually here a rough column is required. So there is no rough column here. So I'll just make a, there's not sufficient space for the rough column, so I'll just make a small space for the rough column. So how electric current or the strength of electric current is defined? It's denoted by the symbol I. So supposing Q amount of charge is flowing in a time t, then charge divided by time gives charge per unit time, because numerator by denominator always gives numerator per unit denominator. So Q is the charge flowing in time t seconds or t units of time. When these two are divided, numerator by denominator, so work by time gives work per unit time, distance by time gives distance per unit time, charge by time gives, or charge flowing by time gives charge flowing per unit time. So this charge flowing per unit time is called as electric current. So from this definition itself, the units of electric current will be coming. Unit of electric current is coulomb per second. So coulomb per second is called as simply ampere. So this is the simple definition of the strength of electric current, simply called as electric current itself. So now what is uniform electric current? Now uniform electric current is also called as constant electric current. So uniform or constant electric current, from the name itself it's clear. Supposing through a resistor, supposing you are taking a resistor, say this is a resistor, through a resistor electric current is flowing. Now very important property of electric current in a resistor or any conductor is, we already seen, so when current is flowing steadily, when a battery is applied, so initially the current increases from 0 to I within a very short time interval, almost 0 time. That's called as unsteady state, when the current is increasing actually from 0 to I. So within a very short time interval this will be happening. Immediately after that, continuously at a constant value current is flowing. Such a flow of current is called steady flow or steady state current. So always in steady state current, very important thing is across every cross section the current will be exactly having the same value. The charge flowing across any given time across every cross section of a single conductor is always the same. So that means the current is always the same at all cross sections. Supposing at between 9 to 9 o'clock to 9:05, current flowing through this cross section is I. At the same time, current flowing through every cross section will be the same. At exactly 9 o'clock, the strength of the current here is, say, 10 amperes. Everywhere it will be 10 amperes exactly at 9 o'clock. So that way the current in a conductor or resistor, every cross section will be the same. So simply this itself is called as current flowing through the conductor. So each and every word or phrase has its own fixed meaning in science and technology. Exactly they are defined that like that. So current in a conductor is nothing but current passing through every cross section of that conductor in a given time or at a given time. Exactly at a time or exactly in a given time interval. So time interval is nothing but the difference between two times. So time exactly at a given time, instant of time is 9 o'clock. Exactly means 9 o'clock means exactly 9 o'clock. So time interval means it's a difference between two times, two instants of time, 9 and 9:05. The time interval is 9 t2 minus t1. 9:05 minus 9. It's nothing but 5 minutes time interval like that. So now what is uniform electric current? From the first name itself it's clear. So current flowing through the conductor. So whatever things we are seeing here are simple, nowhere any complication is there. So the meaning of uniform or constant electric current is, with respect to time, as time passes, the strength of the current should be always the same. So we are considering this conductor means any particular cross section of the conductor we are considering, say the first cross section. Any cross section can be imagined. So initially at 9 o'clock the current is, say, 10 amperes, 9:1 also 10 amperes, 9:2, 9:3, 9:4, 9:5, 9:10, 9:15, 9:16, everywhere at all times the current is there remaining the same. That's called as simply uniform electric current. So more exactly, so this is the rough meaning of electric current. So what is a non-uniform electric current? Is current will be not uniform, it's varying. That's also called as variable electric current. So this is the rough meaning. Now exactly it has been defined. So what is the exact or scientific definition of the uniform electric current? So the thing is very clear. Supposing current is changing, initially current is, say, 10 amperes. Immediately little later current suddenly changes to 15 amperes. Current is small initially, means small amount of charge will be flowing in unit time, because current charge flowing in unit time itself is called as electric current. Current is small means small charge will be flowing in unit time. So in the next time interval, in the next unit time, same, more charge is flowing, that is more current. So then it is not uniform. Uniform means always 1 second current flowing is some value, next second also it will be same value. That means equal time intervals, equal charges will be flowing. That's the main property of uniform electric current. So based on this, exactly uniform electric current is defined. Any current in which equal time intervals, equal amounts of charges flow. So equal amounts of charges flow in equal time interval. That itself is called as a uniform electric current. So this is the basic meaning of uniform electric current. So even more exactly it has been defined. It's slightly extended. So in equal time intervals. So I'm just observe here. Equal time intervals. Say I'm taking exactly 1 second time interval. Next another 1 second. So in equal time intervals, same amount of charge will be flowing. So first 1 second, exactly 1 coulomb of charge has flown. Next 1 second, again 1 coulomb. So like that, next 1 second, again 1 coulomb of charge will be flowing. So in equal time intervals, equal amounts of charges are flowing. Then it is called as uniform electric current. But even this is also not exactly uniform electric current. More exactly, it is defined. Slightly one point, a very important point, extended point to what we have seen is not just these time intervals in equal time intervals, not just this particular 1 second, 1 second, not just 1 second and 1 second. However small the time intervals may be, that means even if we take even smaller time intervals, say half second. So 1 second, 1 coulomb is flowing, say, supposing half second, half coulomb should be flowing. Another next half second, another half coulomb. So 2 half seconds means 1 second. So 2 half coulombs means 1 coulomb, like that. However small the time intervals may be, in equal time intervals, equal amounts of charge should be flowing. Then it is called as uniform electric current, however small. So just observe here. So whatever things we are seeing here are simple. Now so this is the basic thing. So equal time intervals, we have taken considerable time intervals, not very small. 1 second means easily we can measure the 1 second using a stopwatch. Now if we take half second, still smaller time interval. So first half second charge flowing is exactly half, should be exactly half coulomb. So whatever, not just half coulomb, however small it is. Next half second, again another half coulomb, whatever it is. But now just see here. So half plus half is how much? 1 second. So in 1 second, total charge flowing through the conductor is how much? Half coulomb plus half coulomb, 1 coulomb. So next half second again it should be half coulomb. Next half second again, fourth half second is again another half coulomb. That means in third and fourth half seconds it is again half plus half is just 1 coulomb. So that's nothing but the second 1 second. So like that, however small, not just even half second, even can take the still smaller time intervals, say 1/4 second. So 1/4 second again, it should be easily we can guess 1/4 coulomb of charge should be flowing. It can't be different. It can't be different. If it is something else in the first next half second, supposing 1/4 second, it is not 1/4 coulomb, it's different. Again, it will, so easily it can be checked that the current is non-uniform from the definition. Immediately in next step we'll be seeing that more clearly. So not just so, now the simple meaning is very simple. So equal time intervals, equal amounts of charge should be flowing, not just a particular time interval like 1 second or half second. However small the time intervals may be, in equal time intervals, equal amounts of charge should be flowing. Then it is called as a uniform or constant electric current. So this is the simple meaning of the uniform or constant electric current. Now easily it can be seen that this definition is comparable to the definition of uniform velocity or uniform speed. So how uniform velocity is defined? Equal displacements in equal time intervals, however small the time intervals may be. Or uniform speed, how it is defined? Equal distances in equal time intervals, however small the time intervals may be. Exactly the same way it has been defined, uniform or constant electric current. So now, so whatever things we are seeing here are simple, nowhere any complication is there. Now just observe here one small thing. Actually there is no sufficient space here, so I'll go to the next page.